curved differently, serves outward. And the ray acts as if it's coming right through the focal point. And so this actually is a virtual ray. This is a real ray. That's the real ray. But the virtual ray acts as if it comes right through that focal point. So that's the difference between a convex and a concave. Again, if we have parallel in, comes out, it bends out, it bends out, but it acts as if it comes right from the focal point. This is, in this case, we have what we call a converging, a converging lens. It converges the line, the rays down to a focal point. Here we have what we call diverging lens. The rays come in and they diverge away. Okay? So that's just kind of the basic differences between a convex lens and a concave lens in how it deals with the focal point. Okay, I'm going to erase this now. Okay, now what we're going to do, and the time remaining, is to solve some problems. Actually, just right in the book. Okay, flip over to page 407, and we're going to look at that example problem on page 407. Now, here's a rule of thumb. When you draw a lens, draw it real thin. Do not draw it fat. Whoops. You draw your optic axis. Now, as a matter of fact, what I tell students is, I didn't try to draw this straight, did I? Is to draw the lens just like a straight line. And then if you want to just kind of sorry, I hope it hasn't been off for too long. I got unconnected. I hope that sounds better. Okay. So, we have the three rays, exact same thing. Ray number 1 is parallel in, and it goes through the focal point. So, we come in, parallel, and it bends. Notice I'm just bending right at the perpendicular lens, the thin lens idea, and it goes right through the focal point. Okay, that's easy. This is number 1, parallel in, and it goes right through the focal point. That's number 1. Okay, ray number 2 goes through the focal point, and then it's parallel out. Okay, so how do we do that? We go through the focal point. Okay, that's the only way to go through the focal point is to take the ray right down here. Okay, go through the focal point all the way down here, and then parallel out. Okay. So there's, you know what, I need to, I'm going to erase this over here. Okay, so ray number 1 was parallel in, whoops, and it goes through the focal point. Thus, ray number 2 is through the focal point and then parallel out. So it goes, here's number 2. Goes through the focal point and then it comes out parallel. Parallel out, okay? Ray number 3, this is where it's a little, remember, for a mirror, ray number 3 went right through the radius, okay? Well, for a lens, we do not have a radius. So for the lens, the ray number 3 is actually even easier. Ray number 3 simply goes right through the lens center on the optic axis. And it doesn't diverge any. It simply goes right, it doesn't bend any. It simply goes right through. So we take, here's the center of the lens, right on the optic axis. We simply take a ray right through the center of the lens, and we'll keep on going. So here's ray number 3. So where are all these rays going to diverge? Excuse me, where are they going to merge? Well, you can see where they're heading. So let's finish this one. Okay, here's number 3, and here's number 1. Whoops. According to what I get right there. Okay, so here's number 1, here's number 3. So what do we have? We have that they all converge right here. And here's our image. Okay, so let's repeat what we have. Excuse me, need to check something. Oh, who's this? Excuse me, just for a second. All right. Okay. So what we have here is excuse me. Sorry. What we have here is the ray number 1 is parallel in, and then it goes through the focal point. Ray number 2 goes through the focal point and is parallel out. Ray number 3 goes right through the center of the lens and doesn't deflect any. There's ray number 3. And so the image here is formed over here. So the image is, first of all, if is the image real or inverted? It's a real image because all the rays of light are converging at one point. Okay, and these are real rays. We could put a sheet of paper here, and these rays of light would form right here. It's a real image. Notice it's inverted. Okay, it's inverted. The object is this way, but the image is upside down, and it's magnified. The image is greater in size than the object. Okay? Okay, so now that's the example for the thin lens. Now we're going to quickly do the last one, which is, look on page 409. Okay, we're going to do this one on page 409. What we have here, we're going to draw, this is a concave lens. Well, excuse me. We call this a diverging lens. Diverging lens. We draw it as a thin line. Whoops, and then we can add the idea that just thinly, it's actually shaped like this, but we're really going to use the thin lens idea. And the focal length is 5 centimeters on either side. Here's the focal length. Here's the focal length. And the object is 2 centimeters away. So here's the object. Okay, so this is what we call a diverging or we could call it a concave lens, but it's called a diverging lens. Okay? So, ray number 1. Okay, remember parallel in, and it goes through the focal point. So, come parallel in, but it's going to diverge out, but it's going to diverge out as if it's going through the focal point. Okay? Look, see how I drew this as a dotted line just to remind myself that this is number 1. This is ray number 1. It goes parallel in, but it diverges out, but it acts as if the virtual ray came through this focal point. Okay? And number 2 is through the focal point and then parallel out. Okay? Through the focal point. Okay? Whoops. Let me check on something. Okay. Now, we can't, in this case, this is where a divergent lens gets a little tricky. We're going to be going through the focal point, but it doesn't really get there, because then it comes parallel out. In other words, this ray, this is number 2. Number 2, it acts as if it wants to go through the focal point, but it never gets there because it's diverged away. But it comes out parallel. Okay? And number 3, it goes through the lens center. Through the lens center. So we go, actually, here's the center of the lens. We go right through the center of the lens. Here's number 3. So the question is, where do all these rays converge? Well, we have to back up. Okay? this ray here, notice that ray number 1 has a virtual ray that comes right through this focal point. Oops. Ray number 2, this ray coming back this way looked as if it comes from right here. Okay, if the ray number 2, if we back it up through the lens, it looks like it came from here, and ray number 3 hits right here. So we have an image right here, and there it is. So it's formed on the image is formed on the left-hand side, okay, of the, but notice, okay, this image, what is the image? Okay, the image, is it real or virtual? Well, notice we can only do it by coupling two virtual rays, that virtual ray and that virtual ray. Okay, so the image is a virtual image. You can only see the image if you're on this side of the lens. On this side of the lens, looking that way, you can only see the image. Okay, it's a virtual ray. Is it upright? Yes, it's upright. And it's reduced. It's reduced in size. Okay, so this is an example of how you would work these kinds of problems. So there's a little bit more about the eye in this chapter, but this hopefully gives you a good idea of how you solve these problems. And again, let me reiterate, the only way to work, to do well on these homework problems in a test is to work lots and lots of problems. You have to draw them. Okay, God bless you. So long.